So welcome everybody to this latest A2 video on trigonometry, and in this video we'll be following on from our compound angle proof to have a look at some of the more commonly asked questions around compound angles. Now before we get started working through some more commonly asked questions involving the compound angles, identities and formulas, it is important to refresh ourselves with the exact values of certain trig ratios. Now we looked at these values in AS, and even though the exam is that you're allowed a calculator, and most now scientific calculators will automatically give you the exact values, whether it be involving a surd or simple fraction, it is still important to know these values that are unrationalized. So let me just make a little note saying these values are unrationalized in terms of the denominator. Now, typically speaking, in show that questions which will be involving in this, or you're proving a particular thing, then it's important that you are able to understand that there are two possible solutions that both equate to the same answer but written very differently. So for example, if I was to enter sine 45 on my calculator and not recognizing that sine 45 is 1 over root 2, that sine 45 on the calculator gives me my answer as root 2 over 2. Now this here is where the denominator has been rationalized. So, however, in a show that question, rather than using root 2 over 2, they actually want you to use 1 over root 2, and I'm not too sure what is going on there. There we go, back to normal. And so it is important that you're able to recognize that the two things may be written. So yes, your calculator will give you root 2 over 2, but you need to be able to remember that sine 45 is 1 over root 2, and commonly for tan 30 that's going to be 1 over root 3, whereas if you enter that tan 30 on your calculator, it will give you your answer as root 3 over 3. So just be wary of that when you are working with these types of questions, that ideally you want to be working with this variation of where the denominator hasn't been rationalized, rather than using the values where the denominator has been rationalized. So let's get started on this very first question. So here we've got a true-false question. Now, I'll be honest with you, you're not going to get full marks simply by guessing true or false. You're going to have to show some working out with regards to these types of questions. So let's have a look at this first-hand side. So if I just select a decent color. So let's have a look. So in terms of sine 30 plus 30, then that's going to give me sine 60. And if I look back at my table, that sine 60 is root 3 over 2. Now if I then have a look at sine 30 plus 30, then sine 30 is given to me as a half plus a half, which equals 1. So therefore, as root 3 over 2 is not equal to 1, this statement is false. So let's have a look at the next couple of questions. Now with these types of questions, we're now being asked to find the exact values of sine 75 and tan 15. Now you've probably noticed that if I then just quickly scroll up to this table, that you'll notice that we haven't got sine 45 or tan 15, which is what we're trying to find. We've got quite awkward numbers. Now for these types of questions, what you want to try and do is use the numbers. So using the numbers, so a bit like countdown. So we've got 0, we've got 30, we've got 45, we've got 60, and we've got 90. And these are the numbers that you can play with to try and find these little unique angles that we have got. And this is where the compound angle formula really comes into play. So for example, with A, we've got sine 75. Now I can write sine 75 as sine 45 plus 30. Now from this, I can't just simply, like we showed in question 1 with the true false, I can't just write this as sine 45 plus 30. I've got to use the double angle formula. So using the double angle formula, where 45 is going to be alpha and 30 is going to be beta, so what I end up with is sine 45 plus 30 is going to equal sine 45 cos 30. Now because there's a plus, I'm going to use a plus for this one, and I've got cos 45 sine 30. Now from this, what I can then do is use those exact values of which I do know. So sine 45 is 1 over root 2. Cos 30 is root 3 over 2. Plus cos 45 is 1 over root 2. And sine 30 is a half. Now if I then go on to work that out, again, you can always use a calculator, but again, we want to try and leave it so given evidence that we've not used a calculator. This gives me root 3 plus 1. Now just recognize that only the 3 is being rooted, not the 1, so just be careful in terms of your presentation. And that's all over 2 root 2. Now if I then did go on to rationalize the denominator, then my final answer would look like root 6 plus root 2 all over 4, and there is my final answer. So either of those two answers depends on how the question's asking. If it's insisting on you using rationalised denominator, if it's not, if it doesn't mention anything about rationalised denominator, then I would say that this answer here would be absolutely fine. But if it's a show that question, then obviously it could be the rationalised answer. So let's have a look at B. So let me just get rid of all of this so we've got a bit more space. So again, using the numbers of 0, 30, 45, 60 and 90, I want to try and make 15. So looking at B, I've got that tan 15 equals tan. I'm going to do 60 minus 45. Now for this, again, 60 is going to be my alpha, beta is going to be my 45. So then using the formula of tan with these compound angles, so here I've got tan and I've got 60 minus 45, in which then substituting numbers in of alpha and beta, I get tan 60 minus tan 45. The sign's the same. And at the bottom, I've got 1 plus, which is the opposite of the sign that's in the bracket, and then I've got tan 60 tan 45. Now from this, all I've got to then do is substitute my value, or substitute the exact values of tan 60 and tan 45 as per in the table, in which I get root 3 minus 1 over 1 plus root 3. And then again, if I then rationalize the denominator, that then gives me 2 minus root 3. And again, this here is just being rationalized. And there is my final answer. Now the next question, which is given that A and B are acute angles with sine A equals 3 over 5 and cos B equals 12 over 13, find the exact value of cos A minus B. Now with these particular questions, in order to solve, I need cos A and I need sine B. So obviously it's going to involve a double angle. So looking at this is going to involve, and I'm going to need to know what sine B is, and I need to know what cos A is going to be. Now in order for us to find those two things out, what I need to do is split this to work out the value. So let me just write working out sine B and cos A. Now if I take sine A equals 3 over 5 and I draw that right angle triangle, now this angle here is A. Now in terms of sine, when do I use sine? Well, I use sine when I know the opposite and the hypotenuse. So here my opposite is going to be 3 and my hypotenuse is going to be 5. So then using Pythagoras, I get 4 as my adjacent. Now I know all the sides of this. What I can then do is work out what cos is. So here, therefore, cos A. Now cos A, I need to know the adjacent over hypotenuse. And now that I know what the adjacent is, which is 4, cos A is going to be 4 over 5. So let me just put these little things in little bubbles. And then if I then work with cos B, so if I draw another triangle, and this time that angle there is going to be B, and I've got that cos B equals 12 over 13. Well, to use cos, what do I need? I need the adjacent over hypotenuse. So here the adjacent is going to be 12, so that's going to be 12, and the hypotenuse is going to be 13. So using Pythagoras again, I'm going to get 13 squared minus 12 squared, which gives me 25, rooted gives me 5, and again that's using Pythagoras. So then what I can then do is work out what sine B is going to be. And again, how do I find sine? Well, that's using the opposite over the adjacent, opposite over hypotenuse. So that's going to be 5 over 12. And by doing that, what I've now got are all of my 4 components. So the 2 are given in the question, and the other 2 I then need to find. So from this, if I just write down what I've got, so I've got that cos A equals 4/5. I've got that cos B equals 12 over 13. I've got sine A equals 3 over 5. And I've got sine B equals 5 over 12. So now when I work this out to work out what cos of A minus B is going to be, using sort of the identities that I've worked out, and I should know this is on the formula sheet or it's covered in the previous video, so let's just write it out. I've got cos A, cos B, plus, because I've got a minus in the bracket, it's opposite sign, sine A, sine B. So then substituting these exact values into this, I've got sine A, which is 4 over 5, times cos B, which is 12 over 13, plus, let's get a different colour, and I've got sine A, which is 3/5, times sine B, which is 5/12. And if I then go on to work that out, I get my final answer of 63 over 65. And again, I would leave that as a fraction because we want to try and keep our answers as accurate as possible.